Today we are going to work with rational exponents. And our objective is to be able to simplify expressions with rational exponents. Just like in foreign languages, okay, if you were in a Spanish class and your teacher said, hola, como está?
I don't know what that means.
Okay.
What do? You translate it into English, and what do? You
Say it back in
respond in Spanish, okay? So there's, in math, there's different languages within itself, okay? Just like in Spanish, there's different dialects, okay? And so you have to think of math as a language, and within the math language, there's different dialects. So today, what we're gonna learn is that there's different ways to write the square root, cube root. Any radical can be written in a different form, right?
Correct.
Yeah.
So, and I kind of went over this stuff last week. I gave you a sneak preview. Did you know that the square root of 36 can be written as 36 to the 1/2 power? Now, where does all this stuff come from? Do you remember?
The denominator's in the column from whatever the index is.
Yep. The denominator is the index. And where is the numerator? Where did the 1 come from?
The power.
It's the power. Do you guys remember what this number 36 is called? It's the radicand. So now you have to get used to, if you see a number and it's raised to a fractional, we call this a rational exponent. That's what this is. It's a rational exponent. When you see a number to a rational exponent, it's just a radical number. So we just took a test on radicals. We can do this stuff. So you have to be able to convert from one language to the other, so that way you can solve this. So when you see the square root of 36, or you see 36 to the 1/2 power, it means the same thing. And what is the square root of 36? 6. Same with this one. The cube root of 64 is really 64 to the 1/3 power, and the 4th root of 16 is 16 to the 1/4 power. Okay? All right, here we go. Next.
The fourth root are 16 too. Don't you like?
Yeah, you can simplify it. So what is the 4th root? What is the 4th root of 16? 2. And what is the cube root of 64? 4. 4 to 4 to 4. All right. All right, now let's do these ones. Problem number 1. And this is where I apologize because I know it's hard to read this. This says 216 to the 1/3 power. So you should say, that means the cube root of 216. So what 3 numbers multiply to give you 216? Anyone know? It's 6. Check this one out. What did we say? This says 7 to the 1/2 power. Well, what is another name for 7 to the 1/2 power?
Square root of 7.
Square root of 7 times the square root of 7. We just learned that when you're multiplying radicals, and if the indexes are the same, it's going to be, you can take from the other one to make a set, and what's this answer? 7, or square root of 49 is 7. Okay, what about this one? 5 to the 1/4 power is the same as the 4th root of 5, and then times the 4th root, let me write this, this is hard to read, 125 to the 1/4 power, which is the 4th root of 125. So does anyone know, do we have 4 sets of a number?
No. Yeah.
Yes.
Yes.
Set of 5s.
These are 3 5s right here, and this is another 5. So you have 4 5s, your answer is 5. Now, go back to this problem right here. Do you remember the property when bases are the same and you're multiplying? Do you remember what else you could have done with these 2 powers? So for example, if you have x to the 2nd power times x to the 3rd power, what's this answer? X to the what? You add them, right. So what is another way you could have approach this problem. Bases are the same and you're multiplying, so you could have added these, what's a half plus a half? A whole, 7 to the 1 power. 7 to the first power. So that's another way you could have done this. Okay? So let's do these right here. What is 64 to the 1/2 power? Well, it's really the square root of 64, which is 8. How about B? This is saying the square root of 11 times the square root of 11, which is 11. And try C. This is saying the square root of 3 times the square root of 12. What would you do here?
Root 36.
Yeah, some people would put it together and write square root of 36, which is 6. And me, I would write 2 times 2 times 3, and I'd say, oh, look, we have a pair of 2s and a pair of 3s, and 2 times 3 is 6.
I feel like if you had a bigger number, it could make more sense to do
Yeah,
that, but
yeah,
for polynomials,
exactly,
it's-
exactly. I agree. Two people agree. Okay, now, do you remember, we're gonna convert between exponential and radical forms. Check this out. I know this is hard to read.
To the big seven.
Can you read it? Brett, can you see this on the camera?
I'll check to see. Yes, I can.
Okay, this says x to the, I'm gonna say 3/7. How would you convert this to radical form? The what? What's the
The
index?
seventh
The
root of
Seventh
x
root
cubed.
of
X cubed.
x cubed, excellent. Now, if it were top heavy, I'm just gonna go one step further with you guys. If this were top heavy, do you know what I mean by top heavy or bottom
The
heavy?
numerator would have been bigger.
Yeah, so let's look at this let's investigate this for a second. So we've got x to the 7/3 versus if it were x to the 3/7. This is bottom heavy, this is top heavy. Well, this one we just did. This is the 7th root of x cubed. If it's bottom heavy, you can't simplify it. But if it's top heavy, you can convert this to,
X squared.
can you make this a mixed number? 2 and 1/3, right? Now, I showed you this last week, but I don't know if you remember this. So, see this whole number right here? That would be how many whole numbers would come out of the radical. I'm going to show you. So it'd be x squared, and then the 1/3, you've got x to the 1/3 power, so you're going to have the cube root of an x. See this 1/3? That's the fractional part that you can't simplify. So another way you could look at this, see this x to the 7/3? This is what you have, the cube root. That's what you have. Now you have, this is the long way. You have 7 of these, right?
Yep.
1, 2, 3, 4, 5, 6, 7. So what are we looking for? How many of a kind? 3. There's one set and there's 2 sets. So you have x squared, that comes out, that's what we got up here. And then we have 1 remaining, it's the cube root of x. Do you see how that, it's the same thing? So you could make it a mixed number, so 2 and 1/3, and that whole number is what comes out and the fractional part stays. So if it's top heavy, you guys, you can simplify it. If it's not top heavy, you can't, you just rewrite it. So that's how I remember this. Okay, now what happens, let's look at the other example. What happens when you have a negative exponent? What is a negative exponent telling you to do? Flip it. So let's first flip it. So it's y to the positive 3.5, 3.5 power. Well, what's another name for 3.5 written as a like fraction or mixed number? Isn't it 3 and 1/2, right? So how would you write this in they want it in radical form, because right now it's in rational form. So how would you write this in radical form? What's the whole number here? Y to the 3rd. So it's gonna be y to the third power, what's the fraction part? Square root of a y. Does that make sense? Now, we learned last week how to do what to this fraction?
So that you don't.
We could take it one step further and rationalize the denominator. How would you do that? So it'd be square root of y over,
Y to the fourth.
yep. Now that would be your best answer. Your best answer. Questions?
What are you gonna expect?
Well, if it just asks you to write it in radical form, then I would just leave it like this. If it says simplify, then you have to get rid of the radical. Okay. Let's try the next one. B. How do you write that? How do you write this in exponential form?
Two.
A,
Over two.
okay. Now, is it top heavy or bottom heavy?
Top heavy.
It's top heavy, so can we simplify it?
A squared root squared.
It's 2.5, right? 5 halves is 2.5, so it'd be a squared, and then times the square root of a. Easy? How about the next example? You've got B, you've got 3 of these. This is gonna be B to the 3/5 power. Now, is this top heavy or bottom heavy? So you can't do anything with that, or leave it.
You've kind of lost me in how you've done that one now.
Which one?
What you just did. So every time there's an exponent on the outside, that's going to be the numerator.
Yes,
Covering
this
the
is the
whole thing.
numerator, yeah. Because this is, you guys, think of this as, this is what you have, B,
Okay.
another one. And another one. You get that, Art?
Yeah.
You have 3 of these. So really, if they're all the same, you really have the 5th root of B cubed, which is B to the 3/5. You get that?
So the final answer will be.
That's it. It's in exponential form. Okay, let's try, got it. Now this reads W to the negative 5/8 power. W to the negative 5/8 power.
So W
So-
to the 8, or 1.
1 over W to the 5/8 power. Right?
Yeah.
Why did I get rid of that negative?
You get a negative.
We want positive exponents. Now convert it. One over the 8th root of W to the 5th power. Do you get this?
Yeah.
Okay. Next one. This one has a decimal.
Can you simplify
Move
that
it down.
one with the-
Up. Down. Okay. You can you make a decimal? How do you change 0.2 to a fraction?
So it's
2
2
over
times, so
10.
2.
I heard 2/10, which is good,
But
Which
can you
is?
simplify
1/5.
it? Okay.
For the first one, don't we multiply to get the radical of the power?
You can, but we're just gonna leave it for now. I'm not teaching you,
Rationalization.
yeah, we'll never finish this. I just wanna get to simplifying it. Yeah, you can do that after. But how do you convert this now? We want it in radical form. 5th root of W. So we went from W to the 0.2 power to the 5th root of W. Now, why is this really super, super important to you guys, especially right now?
Because if you're trying to rationalize, you can't do it when you set the exponent, you need to actually do the radical.
That, and you got an ACT test coming up, and they're gonna write W to the 0.2 power, or they're gonna write the 5th root, and you've got to be able to convert from one form to the other. It's the same answer, you got to know what each one means. Okay, now how do you do B? Try B for me. Read the directions. It says, what are the expressions in exponential form? These are in radical form. So can you write this in exponential form?
X and
What would this one be?
3. X to the 3/4.
X to the 3/4, excellent, and it's bottom heavy, so you can't do anything. What about this next one?
Y to the 4/5.
Y to the 4/5, and we're done. Okay, now, in this little take note box right here, it goes over all of the properties, which you all know very well. Let's run through them really fast. If you're multiplying and the bases are the same, what were you taught to do with the exponents? Add them. What about if you had something like this, a power to a power? What did you do with them? You multiplied them. This one's just showing you that if you had something like you had two numbers in here, you distribute. Yep. What about a negative exponent? Flip it. What about if you have bases are the same and you're dividing, you subtract. We're going to use this one a lot. And what about if you have a fraction and you have a power outside? You give both of them. You just took a test on that. Okay? So now, check out problem 4. Check out problem 4. It says, it reads the 4th root of x cubed over the 8th root of x squared. Well, we learned last week that if the indexes are the same, we can simplify it. This you can't simplify, right? So last week or yesterday you would have said not possible. Well, now I'm going to give you the tools to do this problem. Because you really can do it. You just didn't know. So what you're going to do, you cannot cancel these out. You don't have the right to cancel these out because these indexes are not the same, or I should say indices. These are not the same. If these were both 4s or both 8s, then you can cross them out. So what you're going to do is convert. How do you convert the 4th root of x to the 3rd? How do you convert it to a rational? X to the 3/4. Thank you, Alex. How do you convert the 8th root of x squared? X to the 2/4. Is there another way to write? I'm sorry.
To the 8th.
Yeah.
So you're just
I'm
putting
going to
an
write it
exponential
first.
form?
Huh?
So you're just putting an exponential.
Exponential. And now another name for 2/4 is
2 8ths.
1/4. 2 8ths is 1/4. Sorry, can't talk. So all I did was reduce this fraction. 2 8ths is reduced to 1/4. Now what did we learn about, or what do we recall about when we're dividing and bases are the same? All we have to do is subtract these exponents. So what is 3/4 minus 1/4 is equal to 2/4. And isn't 2/4 1/2?
So if you come.
And then, now here's if somebody asks you a question in Spanish, how do you answer it? In Spanish. So let's look at the question. The question is asked in radical form. You really should answer it in radical form. That's the proper way. That's the proper way. But these are all correct answers. They're just different variations of the answer.
So you can always simplify whatever exponent you come up with, if it's simplified.
Yes. Yep. So let's try a couple more of these. Got it 4A. So we're reasoning here. We're reasoning. We're using the rules that we learned in the past, the properties, and we're applying them to these problems. So how do you think you do this problem? It says the square root of 3 times the 4th root of 3. Can I steal from this and put it together? No, you can't, because their indices are different. So you're going to treat this as 3 to the 1/2 power, and you're going to treat this as 3 to the what power? 1/4, right? Now, when bases are the same and you're multiplying, what's the property tell you to do? Add what? Add the exponents. Who taught you how to add two fractions?
Third grade teacher.
Okay, how do you add two fractions?
Yeah, for common denominator.
Okay, so let's think about who your third grade teacher was.
So do you multiply the whole 3 or just the
No, you
exponent?
leave the 3 the same, you leave the 3 the same, and you're gonna add a half plus a 4. Did everybody hear what Nick asked? Do you multiply these? Everybody.
No, I meant for the common denominator.
You gotta get the common denominator
Right.
would be 4.
Right, so to get to that 4 from that 1/2, so you're not even touching the base number when you're.
Correct.
getting rid
Right,
of
right, right, right. You're just simply adding 1/2 plus 1/4, like that. You gotta get a common denominator. Your common
Right.
denominator is 4. You multiply this by 2, so 2/4 plus 1/4 is 3/4. So your answer is 3 to the 3/4 power, right? Now how would you convert this? Because remember, the question is written in radical form.
Forward.
You would write the 4th root of 3 cubed. Now can you write it even another way?
Simple.
4 through 9.
Not 9,
27.
27.
Oh,
Now these mean the same thing. The 4th root of 27. Okay, anyone think they can talk me through B? How do you do B?
yeah, put it
That's
into
cube.
exponential.
Okay, what is it? What's the numerator in exponential form?
3.
X to the 3 halves.
3 halves over x to the,
X to the 2/3.
okay, now bases are the same, and what operation are we doing? Division. So what do we do with these exponents?
Subtract them.
We have to subtract them. 3 halves minus 2/3. What's the common denominator? 9/6 minus 4/6 is 5/6. So what's my answer?
X is
Did you get this? Okay, one more. See. We have 7 to the 1/2 power times 7 to the 1/3 power.
just like the first one.
Yep, you're gonna keep the base the same, and you're gonna add, what's a half plus a third? Is it 5/6? So it's the 6th root of 7 to the 5th. Questions? Okay. Now, this next problem, they show you 2 different ways to do it, method 1 and method 2. I prefer, you can, when you're at home, look at method 2, see if you understand method 2. I think I can make method 2, I can make it even easier for you. How's that? I have method 3. Here's method 3. It says, off to the side, I want you to write 16 to the negative 2.5 power. So I have method 3 here. Okay, so what did I tell you? If you see a negative exponent, what did I tell you to do?
Put it on the bottom.
Put it on the bottom. So does everybody agree that this is just 1/16 to the positive 2.5 power? Okay? Now, do you remember what I told you about a whole number? See that 2.5? You know it's 2.5, right?
Yeah.
So you all should see, this is really 1/16 in the 2.5 power, right?
Yes.
So do you agree that this is 16 squared? And then what does it, and then 16 to the, this is 16 squared,
Those cancel.
and nope, this is gonna be 16, the square root of 16. So it's 16 squared, it's two 16s that come out, and we have a 16 that stays underneath the radical, it's the square root. Does that make sense?
Kind of.
What's 16 times 16?
256.
I think it's
256.
256?
Yes.
So this is 256, and then what's the square root of 16? 4, and then what's this times that? Should be 1,024. So was that easy? Did that make sense?
Yeah.
So any kind of decimal, think of the decimal as you've got a whole part and a fraction. The fraction is just a radical, that's all it is. So look at, let's go to got it, 5A. Everyone look at 5A.
Nothing.
We can't.
What is that?
It's -3 fifths. Nick wants to stop. Okay, so, first, how do you deal with the negative exponent?
1/32 to 3/5.
1/32 to the 3/5. Okay, so what, can you rewrite this?
1/5 root 32. Yeah.
1/5 root
32.
of 32, but I have 3 of them. I have 3 32s. I have a 32, a 32, and a 32. Does anyone know what 32 consists of? It's five of
Five
one.
twos.
5 2s. It's 2 times 2 times 2 times 2 times 2. So do you think you could simplify that? Can you see 5 2s, 5 2s, 5 2s there?
Yeah.
So what's your answer?
1 half.
would be
6.
What is it?
8.
So what's your final answer?
1/8?
1/8, you got it. Why? Because look here, Alexis. This is, you've got 5, you've got the 5th root here. You've got, this is 3 of these right here. And this is 5 2s. You've got 5 2s here, 5 2s here. You got 15 2s. So you got 3 sets of 2s. So you're gonna take out a 2, a 2, and a 2. 2 times 2 times 2 is 8. That's 1/8. You get it? There's 5 2s here. 2, 2, 2, 2, 2. So you're taking 5, there's 5 2s right there. There's another 5, and another 5 here. Okay, how about B? 16 to the, I think it says 3/4, it does.
Yes.
3/4. All right, so this is easy. This says the 4th root of 16, we have 3 of them. This is old school. We got this. So we've got 16, but we got 3 of them. Does anyone know what makes up 16?
4 2s.
Believe it or not, 4 2s. So there's one set,
So it's 8.
another set, and another set. It's gonna be 2 times 2 times 2, which is 8. And what about C? How do you do 9 to the -3.5? 1/9 to the 3.5. What did I tell you about this whole number? So it's gonna be 1/9 cubed, 9 cubed, and then what's this
Square root.
fraction? The square root of 9. What's the square root of 9?
3.
So it's really, you can take out a calculator and do 9 times 9 times 9, and then multiply it by 3.
That's a good round. 2,000.
Okay? Last two. Look what this says. It says, what is each expression in simplest form? Can you guys read that? It's the 2/3 power. You're gonna take -8 and raise it to the 2/3 power. You're gonna take x and raise it to the 2/3 power. See this x, y? This is really, this x, y is really to the 1/2 power. Okay, so we have a power to a power.
3/5.
We have a power to a power. So we have, how do I wanna write this?
That's
You have x, y to the 1/2 power. You're gonna raise this. I would distribute this. I would write this as x to the 1/2 power, y to the 1/2 power, and then you're gonna raise this to the 2/3 power. Whoops, 2/3, sorry.
I don't get this
It's
one
not
at all.
actually all of them.
Huh?
There's nothing.
No, she took it out, she's
Oh,
putting it.
yeah.
I'm distributing this, cause
Yes.
see how there's a parenthesis outside here? So you have to distribute this to everything, everything. So unfortunately, you have a square root underneath here, so this is each 1/2. And now you're gonna have to distribute this 2/3. We distributed the 2/3 out here. Now this is gonna be 1/2. Now what's 1/2 times 2/3? So what's 1/2 times 2/3? Do you know what happens to these two? They cross out. So this is gonna be x to the 1/3 power, and this is gonna be y to the 1/3 power. Did everybody understand? 1/2 times 2/3 is 1/3. So this is what you have. This is what you have right now.
Is that all you're doing?
No, we're gonna see if we can simplify this.
It's not
Now, check out all these right here. Do you notice this is cube root, this is cube root, and this is cube root, and they're all bottom heavy. Leave this number out for a second. Can you do anything with these two right here?
Add them.
We can add these. Bases are the same. I can add these two. What do I get when I add them? I get x, because 2/3 plus 1/3 is 1. So this is just a plain old x, okay? That's just a plain old x. Plain old x outside. What about this? This is gonna be the cube root of y. But what's this? We've got this number. This is
One.
-8.
Never mind.
-8, we're gonna square it, and we have to take the cube root of it.
So 64, so.
So it's gonna be the cube root of 64, which is 4. So that's what's gonna come out. So the answer to this would be 4x cube root y. That's the grand finale.
I don't like that problem.
Yeah.
So you have to do those like work today.
Hmm?
Those will be on the
Yeah, the bottom ones. Now, I wanna go right into these ones. We're gonna kick out half your homework right now. Quickly, number 10. These first 9 are super easy. You're gonna fly through them. Number 10. What is 36 to the 1/2 power? Everybody, I wanna hear everybody. 6. What's 27 to the 1/3 power?
That's 1/2.
Huh?
That's
3.
1/3. This is what they're asking you.
Yeah.
What is it? 3. Okay, what about 49 to the 1/2 power? 7. Now, bases are the same, so we can add these. What's a half plus a half? 10 to the first power.
I just don't.
What about here? -3, -3, -3. We're gonna add a third, a third, a third. What's the answer? Yep. Now this one, you might wanna write out, is the square root of 7 times the square root of 21. How would you do this?
7 root 3.
Yeah, it's, because this is 7 times 3, so you're gonna take the 7 out, 7 root 3. Number 16. This is the square root of 2 times the square root of 32. We
32
learned,
is
we
2,
did
2,
several of
2,
these are 5 2s. So what's your answer? 8. So we've got 1, 2, and then 3, so it's 8. 2 times 2 times 2 is 8. How about the next one? It says the cube root of 3, and then the cube root of 9, which is, answer 3. And the last one, the fourth root of 3, and the fourth root of 27. So, Paige, are you good? Stop, Paige. You're good? You sure? Tell me. 27 is 3 times 3 times 3, so we've got 4 3s. You get it? Sure. Okay, back page.
What was the last one?
Ready? 19. Tell me how to write this in radical form.
Is that a 5?
It's a 6.
Oh.
X
6
to the
root
1/6 power. 6 root of x. 20. Fifth root x. What is this one?
Cube root of x. No.
Is that a 2 or
This is
I think
7?
it's a
That's a
2.
7.
I think it's a
It
2.
looks like x to the
We know
2
it's a
sevenths
7.
power.
Leave out the 2.
Oh, so it'd be the 7th
7th root of x
Squared.
squared. And the next one is 2, I think 2/5. What would you write? 5th root of y squared.
Negative.
1 over.
Okay, let's see if you got this now. They're gonna get 1 over, this is it says negative 9/8. And like I said, I apologize for the bad quality, but
1 over y.
1 over y to the 9/8. Now, how do you make that a mixed number? 1 and 1/8. 1 and 1/8. So how would you simplify it? You don't have to rationalize it, but simplify it. I'll write 1 and 1/8 for you.
Y times the 8th root of y?
Y, and then the 8th root of y. Do you get that? Y times the 8th root of y. How about the next one? I think this says negative 3/4. We're gonna go with that.
1 over.
1 over the 4th root of t cubed. $25. How do you write 1.5 as a mixed? Well, actually, you don't have to
1/2.
write it as a mixed, but some people like to. So that's 1.5. So how would you write that now? T, and then
What's that
square,
X?
oh, I'm sorry, it's an X. That was a T.
X times square root of x?
It's an X, you guys. X, square root of X. And the last one,
1 and 1/5.
it's 1 and 1/5, good job. And then how would you write that? Y, 5th root of y.
That should just be our
Okay, I'm gonna assign the odds, 27 through 66 odd. Can you handle that?
Probably.
The odds? So, do the odds on the rest of this page for the homework.
Am I gonna stop recording?
Are we gonna do the other ones tomorrow? Or are we just
Goodbye.
gonna use